Oh, okay. Right. Well, this is the talk as it was billed, but since then we've done a bit more work, and we have actually submitted a paper to the special edition of ICES Journal, and that this is its name. So we're going to talk about risk screening for ecological effects, and that group of people on there include a multidisciplinary team that did the with the actual working group. So, start off. Basically, Seafish is a government body, but we actually consist of a levy for the fishing, from the fish landings or importings into the UK. It's a statutory levy, so they have to pay it. But we sort of cross the boundary between government and industry. So that's where we come from. So for risk screening, okay, so there's the requirements for to meet international sustainability obligations, you know, from the Rio conference and so on in 1992. Probably started before then, really, didn't it? Now, more recently, I think it's become most intense since the early 2000s. There's been a need for industry to know much more about the sustainability of their resources. I can claim that back in the early 80s I sort of foresaw this, in that I chose to do a project on fisheries population dynamics, but it wasn't necessarily a very attractive option, because you spent a long time out of work. But since the early 2000s, we've had a lot of requests. Well, how can we understand sustainability and evaluate risks? We all have to eat fish, but what are the risks attached to this particular fishery or this particular fish? Okay, so this next question then, for risk screening, all those interactions between man and his environment, which one should actually concern us? We can't examine everything. It's not really. You can't really ask people to do a research project in every single fish stock. So or other interaction, with seals or, strange worms and things like this. So which one should we be concerned with? Whether it's the commercial people or the governmental side. This is where we started. So what do we need? We need a scheme that allows people to bring together information from different disciplines, including the industry, with a clear line of sight between the policy, the idea of which way you want to go, and the consequences of implementation of that policy. So that's the general idea. That's what we're looking at. This is just to remind you, obviously there's people here who don't know where the southwest of the UK is. Just to say this, our study area was the ICES EFGH in the southwest of Britain. We tried to take into account all the fisheries effects here, but as far as mitigation measures, we were most interested in the fisheries that came out of ports along the blue line there, because they were that was the people who had sort of helped us commission the work. So that's the area, just to let you know. Next thing. Right, so when we do a risk assessment, we have to have some sort of principles to start with. We have to think of something framework to work from. So we went and had a chat with the guys down there in Cornwall, especially, and they had this organisation called Seafood Cornwall, which is a sort of development group for the fishing industry down there, and also the processors. The processors were a very strong sort of driving force behind all this, because they get asked all sorts of questions about the fish they're buying and selling, and they get questions from the industry, for the fishers from one hand, and their buyers in the supermarkets on the other. So we wanted to try and help serve those people. So the goals, well, the basic principle is pretty universal, I think. Leave for future generations the same or better opportunities that we have at the moment. And they came up with these various these goals, which I don't think many people can argue too much with. We want an economic system that produces fish. We want to avoid taking too much from the fish stock. We want to try and keep the ecological processes going. We want to protect biodiversity without necessarily just sticking to the letter of the law, because usually the letter of the law comes in when biodiversity has been hammered in some way. Then, of course, minimise pollution and comply with all the legislation. So this is the overall framework they gave us to start with. Okay, so now let's talk about risk assessments. Now, in engineering and maybe health and safety, you talk about the severity of the hazards and the probability of occurrence. Now, we looked at it using the SECO idea, and I hear some Australian accents in the back, so I'm importing something, but we've done a little bit more to it. We used, okay, how big an area and how much interaction is there with a unit? What's the intensity of the effect? And how long does that effect last for? So that's our framework. 4 basic parameters, hopefully, which you can try and estimate independently. Right, some jargon coming, I'm afraid. Agent of change, that's anything that's likely to cause change in an ecosystem. A fishery, gravel extraction, oil spills maybe. That's the overall agent of change. An activity, one of the activities of the unit, towing a trawl, steaming, shooting static gear, soaking static gear, that kind of thing. You can divide everybody's activities up. Unit of analysis, okay, that's a stock, a species, a habitat, or community. That's something you've got to, you can say, well, this is a unit we can work with. An attribute, okay, is a feature of a unit benefiting survival, like abundance, food supply, genetic diversity, lots of things you could look for. An effect is a change, something that actually happens to a unit resulting from an activity. Right, now this is important, the operational objective, and you can refer back to the original goals here. So you can say, well, we've decided that this is what we want to do with this unit because this is our goal. So we'll talk about that later. An indicator is the sort of things that we get, like biomass changes or fishing mortality changes or some other indicator. You don't always get the last 2 when you start to do this kind of thing. People don't necessarily have operational objectives, and they don't necessarily have a viable indicator for a lot of components, a lot of the units of analysis. But you can still do it, but you're not too sure what to do with the result. Okay, next change. Okay, so examples of operational objectives that we thought we'd use based on those goals, initial goals. Okay, so for habitat communities, perhaps no disruption in the basic ecological process or food webs. Favourable conservation status, I think that comes from the SAC legislation, the Special Area Conservation legislation. Fish stocks, what is not quite classical now, but it's what ASCII's use. And then, of course, the data limited assessment version of it. Okay, so biodiversity, this is where we had to sort of think of things that we can use. Secure presence in the southwest, is it present in reasonably viable numbers. Cetaceans actually have their own reference points, with only a few of them. There's not always a lot of information. Seabirds, non-commercialised rates, these sort of things. Okay, you could argue we're making it up as we went along, but we had those goals to start with to be able to make those, to refer back to and say, well, we chose to use this operational objective because you set us these goals. So it's a line of sight approach. Okay, so what you do is you choose for each unit of analysis, the species, habitat, community, choose the activity that is most likely to affect that unit, choose an attribute, abundance, food supply, consider, or whatever, considered like to be most affected by that activity. I'll give you some worked example a bit later. And then you do some scoring, which I'll explain in a minute. And then if you have an operational objective, you can relate it back to the unit's operational objective. You can score as many activities on one unit as you think is like to affect it. And so that's the general idea. Now we actually chose to, because we were doing a very broad risk screening analysis, most of our simple activity was simply fishing. You know, irrespective of gear type or how much, where it was just simply fishing. You could try and make it more fine-grained, but I think that's for later on. So how do you score? Well, for spatial scoring, it's the area. Now I've got to try and make this work now. That area divided by the overall units area. I'm sure it's the same right, but basically, where do the two coincide? So this is, say, a unit of a fish stock, right here, and where does the activity, the fishing activity, coincide with the fish stock? Now, arguably, this is problematical because you might get a whole lot of people doing seekers alongside each other, and you actually end up with everybody says, oh, well, you have a low risk, and the next one says they have low risk, and add them all together, it's a higher risk. So you've got to be careful. But remember, we are looking to prioritize the approach for this particular area. So our interest is to try and see what actions can be taken in that particular area. So, but if you've got units that cover the whole Atlantic, say sea turtles or whatever, you have to understand that and you have to take notice of that and put that in your narrative. But you just got to be careful. Same idea with temporal scoring. Where does the activity in the unit coincide? Right, so, okay, so those two are, you could get an atlas and look them up, maybe. They're fairly, you could probably get a pretty good idea without having to talk to people too much about those two. This one is the intensity of effort. Now this is where you have to bring in stakeholders' thoughts, because you've got to be able to say, well, you know, when you do get this fish, just roughly what proportion do you actually catch? Now, obviously, this is perhaps where subjectivity creeps in, but you might as well try and score. We have to try and score something. We use the same breakpoints for the other spatial and temporal effects. So it's fewer than 10%, up to 10 to 20, and so on. So basically, it's the scores go from 0 to 5, which is basically a very negative effect or no effect, to basically everything gets caught or everything gets affected. So that's the scale, intensity, and the spatial, temporal, and intensity analysis, which is similar to the Australian method. Now, on the final, the other parameter we added was simply how long are things going to last. So, from a single pass of that activity, how long will it take to get it back to where it was? So, say a single trawl, perhaps just disturbing a very dynamic area of seabed, perhaps an immediate recovery or expected maybe in the last few days or weeks. That's number one. And then, so if you demolish a coral reef, that's a permanent sort of effect. So you've got a reasonable set of scales. And you do a score for each of those activities, each of those units of analysis, which I'll actually show you an example in a minute. And you end up with a 1 to 5 scale. So now this here, basically, significant impacts start occurring at number 3. And, but it's essentially a ranking process. The important thing is not to get too hung up on the numbers. It's the process you go through to do the job and then look at the ranking of the various effects. Right, so I'll just explain one example. Now, you can't really see it here. This is the foraging areas, foraging ranges for various seabirds. And as you can see, some of them have quite large foraging zones, but the terns, which live up here, anyway, near Portvoo, where number 5 is, there's a little, you can just about see the range of the tern foraging areas. It's just in this area here. So, most of them have quite a big foraging area. The terns have a very small foraging area. So the question, and there's some pelagic fisheries there, so the question is about food supply for the terns for their breeding. Okay, so that's the unit of the attribute of the terns which we scored. So the fishing activity which might affect the abundance of the small fish, e.g. sprats, but also maybe other ones. The operation objective to main food supply for breeders, and the spatial score because there's fishing going on more or less in that area or on that stock of sprats, so that gets a fairly high score. Temporal score is going on through the breeding season, so that's that coincides well. Intensity, this is where there's probably other small fish about that the terns will eat, so that was scored at a much lower intensity. The duration, okay, if they fail 1 year, they've got to breed the next year, and so there's at least a year there if there's a fail. So the consequence score from the geometric mean came out at about 2.6, which is the highest score we got for the birds. So that's how the system works. It's just 4 parameters, and if you get together a group of people, you can bring expertise together to get a score. Now, it may not be right, but you can show from the original original principles, the operation objectives, this is where we came from, this is what we scored. Next one. Okay, so we scored 103 units with our team, our interdisciplinary team, and this is the histogram with final consequence scores. So, as you can see, we filtered out quite a lot of what we consider to be lower level risks, below 3. But again, be careful not to get too hung up on the actual scores. And these ones over here were higher, the higher risk. So I'm just going to give you an idea of a tabulation of what we got. Okay, so for communities, I'll tell you what they're fine in a minute. The total pairs scored, total pairs looked at were 17. Some we didn't score, and I think on the original technique, the idea was you gave those a number 5 all the way across. We didn't do that. We just said we can't score this. We have to pass it on and get other people to look at it. Numbers scored above 3 were 3 minutes. And these are demersal fish at the large fish indicator and the large species indicator scored above 4. Then those are in the MSFD, what do you call it? Good, that's in the MSFD requirements. So that's somebody's looking at them. What wasn't scored here were pelagic fish and plankton, so they're informed. So basically going down here, we have difficulty with the habitats because we didn't have information. Elasmic ranks, we came out 8 above 4, Telios 1 above 4, and the other ones were quite reasonable. So did we come out with something? Does it meet our aspiration? Well, we managed to get together, we managed to do the risk screening exercise, and we made some recommendations. Okay, so pay attention to the LFI, large fish indicator, large species indicator. Try and improve stock age structure. That's already happening in the sense that fishing effort is trying to be lifted. You're trying to get a better level of large fish. Find measures to conserve the elasmid ranks because they're higher risk. Gain more information on fishing effects on benthic and pelagic, especially in benthic habitats and communities. In fact, the benthic ones were found not too difficult to score. They were a bit thin on information. And then there were certain stocks that looked as though they could improve assessment and management. So that's my first attempt at scale intensity ecological analysis. And this evening I'll talk about a poster about some other work.
Okay.